Okay, so we are going to start doing the circuit in the breadboard. I already have all the materials ready, and first I will use the resistor, but I want to explain that this line is going to be the one that receives 5 volts, and this one is going to be the ground. So we are going to connect the resistors in the 5 volt lines like I show in that way, and then we are going to use our LED. The LED has a larger side than the other one. The larger side is the one that has a high voltage, and the smaller side is the one with less voltage or ground. So we're going to connect the smaller sides to the ground line like that, and then we have to connect the resistor line with the LED line. So we're going to use a jump wire like that. And then we are going to need to use our photoresistor. We have to make sure that the jump wire is connected correctly. So now we are going to use our photoresistor. The photoresistor is the one that is going to make all of this function. And the photoresistor, when it is under light, has a low resistance, and when it is dark, it's going to have a high resistance. So this is going to be the reason why the LED is going to work. We are going to explain this better later, but we are going to connect this photoresistor in with the ground line and with the line of the 1 kilo ohm resistor like that. And in this way the photoresistor and the LED are in parallel connection. So now we have our 9 volt battery and our Arduino. So we are going to connect the 5 volts like right there it says 5 volts. We're going to connect it to the 5 volt line that we have said already at the beginning like that, and then we're going to connect ground GND with the line that we have said is going to be ground like that. So now it is connected to the power of energy. There is going to be the voltage, and we have to connect then the battery. Okay, here I already finished my circuit diagram, and I already connected 9 volt batteries to the Arduino, and now we can see that when the lights are on, the LED is going to be off, but when it is dark, the LED is going to be on. We can do more. While I explain how it works, I will show you more images about my project. The reason why this works it is because the LED and the photoresistor are in parallel connection. Then when the photoresistor detects that it is dark, the resistance is going to be higher, as I mentioned before, and because of the resistance is higher, it is going to be more difficult to the current to flow through it, because the resistor is the one in charge of restrict how is going to be the flow of the current. This means that when the resistance is higher, it is going to be even more difficult to the current to flow through it. So the current always prefer the easy way, the easy path. So for that reason, when it is dark and the resistance is higher in the photoresistor, the current is going to prefer to flow through the LED, and when the current it is in the LED, it's going to turn on the LED. And when the photoresistor detects the light, then the resistor is going to be lower, meaning that the current is going to prefer through this resistance and going to the ground, and then the LED, for that reason, when the photoresistor detects light, the LED is going to be turned off, because it is not going to be any current flowing through it. In conclusion, the current always prefers the easy paths. For that reason, always going to prefer the one with a lower resistance, and for that reason, when the photoresistor is under light and the resistance is lower, the current is going to pass to the photoresistor and return to the ground, making the LED stay turned off. But when it is dark, the resistance is higher, and for that reason the current prefers to flow through the LED, making it turn on. I hope that you liked the video, and thank you for your attention.